Have you heard of van der Waals forces? I'm sure the name sounds familiar. Let's understand these forces in detail. There are three types of such forces. Let's look at the first one, that is London forces or dispersion forces. For that, we need to take a non-polar molecule containing two types of atoms, say A and B. Now, since the molecule is non-polar, the electron cloud, as you can see, is completely symmetrical. However, the electron cloud of any atom, say A, may get unsymmetrical momentarily. And once that happens, it results in the development of small dipole on atom A, which then distorts the electron cloud of atom B. Now these temporary dipoles attract each other. This force of attraction was first proposed by Fritz London, and that's the reason why it is known as London force or dispersion force. Let's look at another type now. We have a molecule which has a permanent dipole. For example, HCl. Now, as you would know, Cl is more electronegative than H, and therefore Cl carries a partial negative charge and H carries a partial positive charge. So the molecules of HCl attract each other with dipole-dipole forces, and these forces are stronger than the dispersion forces that I talked about earlier. There is one more type of force, and that is known as dipole-induced dipole force. Let me explain. Now, this type of attraction rises when we have a polar molecule that has a permanent dipole moment, for example, HCl, when it interacts with a non-polar molecule. Now, what actually happens is the polar molecule induces dipole on the non-polar molecule. How does it do that? It makes its electron cloud unsymmetrical. So this was the third type of force known as dipole-induced dipole force.